Well, howdy kids. This is going to be a video that covers atomic mass units, and what we call a weighted average, or the average isotopic mass for an element. So let's get to it. Atomic mass is not the same thing as mass number. It's actually a weighted average based on how many isotopes are occurring in a given element or a given sample. And these are the values that we actually see on the periodic table. So if you were to look at your periodic table, you would see that the mass numbers are decimal forms. And in the last video we watched, it was whole numbers for the mass because we were looking at single atoms. But these numbers have decimal points because what we're taking is a weighted average, kind of like how we take grades in school. You have weights for tests, you have weights for daily grades, and that's what we're going to do here. So we have lithium. We know lithium is atomic number 3, and yes, this is on top, but we know for sure that the atomic number is always 3 for lithium. This is what we're seeing on the periodic table, something that's not whole. Now, with any measurement, we do have units, so the units for this, we may have seen this before, is atomic mass units, or AMUs. Eventually, we're going to learn that we can use this as grams when we're comparing something called moles, which we'll learn in Unit 5. Atomic mass units is defined as 1/12 the mass of a carbon-12 atom. So if we're looking at this particular unit, it's based off the element carbon. So here's our first weighted average problem. A sample of cesium is 75% cesium-133, 20% cesium-132, and 5% cesium-134. So what you'll see is we have cesium, which is always the element number 55. So all of these have the atomic number 55, but what you'll notice is the mass number is different on each one. So what we have to do is find the weighted average. So let's go ahead and calculate its average atomic mass. I'm going to go ahead and turn our percentages into decimal forms, and to do that I'm going to be moving the decimal 2 places to the left on each one. And on the 5, you're going to have to move it 2 still, so you'll have to fill in a 0 there. So I'm going to go ahead and put it in the decimal form, and you might want to write that in your notes. Use decimal form. And then what I'm going to do is multiply each one by its mass number. So the first one is 133 for the mass number. These are the mass numbers. 132 and 134. And what I'm going to get are the relative weights of each isotope. So I'm going to go ahead and calculate them for you here. And what they did was they went ahead and rounded each one to 2 significant figures. And what you're going to do after that is add up. It's a total. It's a sum. It's a summation. And when you add these guys up, you're going to get the weighted average. This is actually how we calculate our grades. And if we're looking at significant figures, we would look to the right of the decimal when we are adding. And there was 1 to the right of the decimal here, nothing to the right of the decimal here, and 1 to the right of the decimal. So we can't have anything to the right of the decimal. That's why we're going to round the 8 to the 2, which is going to be 133. And our units are atomic mass units. We're going to calculate a major lab and we're going to work through those problems where we have weighted averages, and you're going to be calculating the average atomic mass of a given sample. So let's compare this value to the periodic table. Well, if we look at our calculated value, which was 133, and we look at the periodic table for that particular element, cesium, 132.905, what we see is that, yes, this is an accurate way to find the atomic mass for an element. And we're going to go ahead and stop there for today.